Okay guys, something that you're going to need to know on your Chapter 2 test are the parent functions. I know that sounds weird, how can functions be parents, but we just mean that there's different types of functions out there and you need to know what those types are. The first type that we're going to look at is called the quadratic, and its equation looks like this. Y equals x squared. So there's an exponent of 2 on x, and that graph has three important points. 0, 0, 1, 1, and negative 1, 1. But it's not straight lines connecting them. It's more of a curve. We actually call that shape a parabola. Okay. We'll get to the domain and range when we go over this sheet together in class in the next couple days. So you don't need to worry about that now, but you do need to start to remember that y equals x squared looks like this graph. Alright, the next one is called the cubic, and its equation looks like y equals x cubed. There are three important points on that as well, 0, 0, 1, 1, and negative 1, 1. We do a curved line to connect those as well. So just like that. Some people call this more of like a squiggly shape. Alright, the next one is the square root graph. Its equation looks like y equals square root of x. This graph has three important points, 0, 0, 1, 1, and 4, 2. And we would connect those points by just doing a slight curved line headed upwards. It doesn't increase very quickly, it increases very slowly, just like that. Alright, let's flip it over. The next graph is the absolute value graph, and this equation looks like y equals the absolute value of x. Its shape also has 0, 0, 1, 1, and negative 1, 1 on it, but we use a straight line to connect these points. It actually looks like a V, which I think is convenient since absolute value starts with a V. The next one's kind of tricky. It's going to be one of your harder ones. It goes by the name inverse or rational graph. Its equation is y equals 1 over x. And it has these things called asymptotes. I'll actually spell that out to the side. An asymptote is an imaginary line that the actual graph does not cross or touch. It's kind of like a wall, okay? It's like an imaginary invisible wall. But we want to designate where that wall is, so we use dashed lines to designate where the asymptote is. The asymptote, there's actually two on this graph. One is on the x-axis, and one is on the y-axis. So our graph cannot go through those dashed lines. Part of the graph is in quadrant 1 and looks like this. Okay, sort of like a big L. The other part's in quadrant 3 and looks like that. Don't get too overwhelmed by that graph. We'll definitely talk about it more and you'll get more familiar with it. But for right now, just be familiar with what it looks like. The next function you've never heard of, it's called a rounding up. Sometimes it also goes by the name of ceiling function, so I'll just write that above. Its equation looks like this, y equals, and we have these weird brackets around x. I always think it's like they're making a ceiling above x. That's why they're sort of going in at the top there. And this graph actually looks like a bunch of steps. We have a closed circle at 0, 0, an open circle at negative 1, 0, and we connect them. And that's our first step. Our next step is right above it. Our next step is right above that. And I'm just going to fill in the rest of the steps. These steps do go on forever, but obviously we can't draw that forever, so we eventually have to stop. The next one, called the rounding down, or sometimes called the floor function, looks like this. Y equals, and then we have these weird brackets around x. It also looks like steps, but the open and closed circles are in slightly different locations. We have a closed circle at 0, 0, open one at 1, 0. And then we just move that shape over and up. And you've got your floor function. Okay, those steps do keep going, but we can't draw them forever. Make sure that by the time the Chapter 2 test rolls around, you are ready to go and you know how to draw each of these graphs.